So, as promised in my previous video, here I am. Hi, I am Neha, and today we are going to differentiate dry corrosion versus wet corrosion. I hope you are following my playlist of corrosion. This is my fourth video, and I'm just coming with few more videos on corrosion, its types, and its prevention. Let us go ahead with how to differentiate. So, I would say rather first point would always be if it is dry and it is wet. The name says that here it is dry, that means it's absence of moisture, and if it is wet, that means it's presence of moisture. Presence of moisture, or if you want to be very specific, presence of a liquid, right? So the first point would be the medium. The medium here, its absence, it's present. A liquid medium is there. Second point says that there is the direct attack of like chemical attack is there. So if metal is there and if it is in presence or with in contact with the environment, then there is direct attack of the environment on the metal, and the attack is chemical in nature. While here what happens is the attack is basically electrochemical in nature, and that's how you call this as chemical corrosion and you call this as a electrochemical corrosion, because here there'll be series of galvanic cells or electrochemical cell development on the metal. So there is not direct chemical attack, but it would be a electrochemical attack. Rather, if I would like to say it in a more specific manner, it is electrochemical attack. Fine. Second point is clear. Third point, it follows adsorption mechanism. Adsorption, I hope you remember, on the surface. I'm talking about on the surface. That's adsorption mechanism. While here it happens in the presence of electrochemical reactions, so there is no pattern of a adsorption of the product. Then it is applicable on both homogeneous and heterogeneous surfaces. I have explained this very clearly in my previous videos that the presence of heterogeneity is very important in wet corrosion. Why? Because if the metal is there, single metal is there, the let's say the entire metal sheet is there, how electrochemical setup will be there, how you are supposed to have a anodic area, how are you going to decide a cathodic area, is based on that heterogeneity. If the metal is having some area where there is a dust particle or there is a dirt particle, then this particular metallic area is not in contact with the environment, that is liquid, while this metal is in direct contact with the liquid. So this area of metal which is in direct contact with liquid is different from this area, and that's how this area is anodic and that's cathodic. The area which is in direct contact becomes anode. So there is development of anode and cathode, and it only happens when there is a heterogeneous surface. Coming to the next point, dry corrosion is a slow corrosion. It's a self-controlled process and self-stifling product, right? While here it is fast, it is continuous, and the product are not self-stifling. What do we understand by self-stifling? Means they do settle at where they are formed. So here in dry corrosion they are self-stifling, they settle where they are formed. So if this is a metal and the oxygen reaction is there, metal oxide is formed, so it is settled here where it is formed, right? There will be the product. While in case of wet, what happens is, in case of wet, I hope if you remember, the rust comes out and it settles somewhere between anode and cathode, because the iron moves, right? So depending on the speed of iron, the product will get settled down. So it's not a self-stifling product, means wherever it is formed, it is not absorbed. While here, it is absorbed where it is formed. Coming to the next one, overall uniform corrosion. Yes, of course it is uniform corrosion. Why? Because if the scale is like we have seen, if the scale is stable, if the scale is unstable, or if it is porous, volatile, whatever happens to the entire material as such. So it's a uniform corrosion. While here it is non-uniform. Pitting is frequent where anodic area is small. Pitting, I hope you understand, is the formation of a pit. It's a formation of a crack. So if this is the anodic area, then there is development of a crack. Now this anodic area is small, cathodic area is large. Again oxidation will occur, this pit will become big, and then this pit will become big, and this is how it's going to extend. So the pitting is frequent here. The anodic area is small, corrosion happens here, it's non-uniform, while here it is uniform. So I guess almost all differences are pretty clear to you, and if not yet, please do mention in the comment. I'll definitely answer. And then last would be some examples. Let's say reaction of dry HCl on iron, formation of mild scale on iron, fogging of nickel in SO2 atmosphere, or hydrogen sulfide laden air, tarnishing of silver. These are the examples of dry corrosion. I hope you remember there were three types: oxygen, presence of other gases, and liquid. While in case of wet, there are only two: hydrogen evolution and absorption of oxygen. So example, rusting of iron and moisture, dezincification of brass, stress corrosion or cracking of iron is one of a type of wet corrosion. So I hope with that you are able to understand the difference between dry and wet. I would come up with other types of corrosion in my most coming videos. If you are able to understand the concept, please do hit like and subscribe for more videos. Thank you so much.